Imagine standing on the surface of a distant world, a planet orbiting a star so far from Earth that light itself takes thousands of years to reach it. But this isn't just any world. This is a human world. Cities shimmer beneath the alien. Sky transport ships dart between orbital stations, and somewhere, a child gazes up at the night, seeing an empire of stars her ancestors once called unreachable. Now imagine zooming out, past the planet, past the star system, past the vast spiral arms of the Milky Way, until you see it all. A galaxy not just explored, but controlled. Every planet, every resource, every force of nature bent to human. Will science fiction or humanity's ultimate destiny? At first, the idea of controlling an entire galaxy seems absurd, almost mythical. Our species has barely set foot beyond our own moon. Even Mars, our closest planetary neighbor, is a key monumental challenge that requires cutting-edge engineering, logistical mastery, and generational commitment. So how could we possibly imagine ruling the Milky Way? The answer lies in something fundamental to our nature: progress. If there's one undeniable truth about humanity, it's that we never stop pushing forward. From fire to electricity, from the steam engine to quantum mechanics. Every breakthrough in human history has shattered the limits of what once seemed impossible. And when it comes to controlling a galaxy, the first step has already been taken. Right now, Earth is surrounded by an invisible web of human-made technology, satellites, probes, and telescopes mapping the cosmos in ways our ancestors could never have imagined. The Voyager spacecraft, launched in the 1970s, are already on their way out of the solar system, carrying a message for any civilization that might find them. The James Webb Space Telescope peers deep into the universe, unraveling the secrets of distant exoplanets and galaxies billions of years old. The first whispers of an interstellar future are already here. But whispers are not enough. To control a galaxy, we need something more. A way to move beyond the solar system, to colonize, expand, and master the forces that shape the cosmos itself. The biggest challenge? Distance. Space is unimaginably vast. The nearest star, Proxima Centauri, is over 4 light-years away, meaning even our fastest spacecraft today would take tens of thousands of years to get there. And that's just the first step. The Milky Way stretches across 100,000 light-years, containing over 100 billion stars. If we ever hope to control it, we need to find a way to travel between these stars, quickly, efficiently, and sustainably. New propulsion systems could be the key. Technologies like nuclear fusion rockets, antimatter drives, or even the theoretical Alcubierre warp drive could one day allow us to reach the stars in a fraction of the time. The concept of a warp drive, first proposed by physicist Miguel Alcubierre, suggests that space itself could be manipulated, compressed in front of a spacecraft and expanded behind it, effectively allowing for faster-than-light travel without violating the laws of physics. Though purely theoretical at this stage, advances in quantum physics and exotic energy fields may one day turn this dream into reality. But even with new propulsion systems, traveling between stars is just the beginning. To control a galaxy, we need infrastructure, permanent settlements, self-sustaining habitats, and a way to harness the immense energy required for interstellar civilization. The idea isn't new. In the 1960s, physicist Freeman Dyson proposed the concept of a Dyson sphere, a colossal structure built around a star to capture nearly all its energy output. A civilization capable of constructing such a megastructure wouldn't just be advanced, it would be on its way to mastering an entire solar system. And once you control one system, what's stopping you from controlling 10, 100, a million? But before we dive into what controlling a galaxy actually means, before we explore the challenges, the strategies, and the mind-blowing technologies that could make it possible, there's something crucial you can do right now. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. Now, let's take this idea further. If humanity starts expanding beyond Earth, How would we actually take control of a galaxy? Would it be through sheer numbers, advanced technology, or something entirely unexpected? And what obstacles stand in our way? Let's find out. The first step to controlling a galaxy isn't just reaching the stars, it's surviving them. Space is not a welcoming place. It's a void of extreme temperatures, deadly radiation, and distances so vast they make even our most advanced spacecraft look like drifting specks of dust. Yet if history has shown us anything, it's that the harshness of an environment has never stopped humanity before. We've crossed oceans, scaled mountains, and built cities in deserts. Space, it's just the next frontier. But unlike anything we've faced before, this is a frontier that won't forgive mistakes. So, how do we go from fragile biological beings bound to a single planet to rulers of an entire galaxy? The answer lies in adaptation. Right now, human bodies are designed for Earth. Its gravity, atmosphere, and magnetic shield protect us from the brutal forces of the cosmos. The moment we step beyond our world, we're exposed to dangers that could kill us in minutes. Radiation from the sun and cosmic rays bombarding deep space can tear apart DNA, leading to mutations and cancer. Zero gravity weakens bones, shrinks muscles, and even alters the brain. And then there's time. Journeys between stars could take decades, centuries, or even millennia. If we want to expand beyond the solar system, we need to either bring Earth with us or change ourselves entirely. One way to do this is through advanced space habitats, artificial worlds built for long-term survival. Think of O'Neill cylinders, massive rotating stations capable of simulating gravity, shielding their inhabitants from radiation, and sustaining entire ecosystems. Inside, lush forests, artificial lakes, and human cities could thrive, all while orbiting distant stars. But even these are just stepping stones. To truly command the galaxy, we may have to abandon traditional biology altogether. Genetic engineering could make humans more resilient to radiation, while cybernetic enhancements might allow us to function in extreme environments without the need for oxygen or food. Imagine a future where humanity isn't just a species, but a spectrum. Some might choose to remain biologically human while others merge with machines, becoming something entirely new. And then there's the most radical possibility, digital immortality. If our consciousness could be uploaded into machines, freed from the limitations of biology, expansion would no longer be restricted by time or physical needs. A human mind, existing as pure data, could travel between the stars at the speed of light, beamed across the cosmos as a stream of information. Colonization wouldn't mean sending ships and supplies. It would mean transmitting entire civilizations to new worlds, where they could be reconstructed in artificial bodies or virtual environments. This wouldn't just change how we explore the galaxy, it would change what it means to be human. But let's assume we remain biological for now. Even with advanced technology, traveling between stars is still a challenge. The biggest obstacle? Energy. Moving a civilization across the galaxy requires an almost incomprehensible amount of power. A single interstellar spacecraft, moving at a fraction of the speed of light, would need more energy than our entire planet currently produces in a year. And that's just one ship. If we want to spread across the Milky Way, we need to master energy on a scale far beyond anything we've ever achieved. That's where Dyson spheres come in. These megastructures, massive shells or swarms of satellites built around a star, could capture nearly all of its energy output, providing power levels trillions of times greater than anything on Earth today. With that kind of energy, interstellar travel becomes not just possible, but inevitable. And it doesn't stop there. If a civilization can build a Dyson sphere around one star, why not 2 or 100? Over time, humanity could create a vast network of energy-harnessing megastructures, turning entire star systems into power sources. This would be the beginning of what scientists call a Type 2 civilization on the Kardashev scale, a species capable of using the full energy of its home star. But to control a galaxy, we would need to reach the next level, Type 3. That means harnessing not just a single star, but the power of an entire galaxy. The idea sounds impossible, yet some scientists believe we may already see hints of civilizations like this in the universe. Some distant galaxies emit energy in strange, artificial-looking patterns, while certain exoplanets have unusual infrared signatures that could indicate advanced megastructures. Could these be evidence of Type 3 civilizations? Or are they natural? Phenomena we don't yet understand. If we do one day become a galactic power, would we be alone? Or would we find others who had reached this level before us? And more importantly, what happens when two galactic civilizations meet? This is where things get even more fascinating. Humanity expanding across the Milky Way might not just be about technology and exploration. It could mean encountering something we've never faced before: competition. If we ever hope to control the galaxy, we need to consider one crucial question. Are we the first? Or is someone or something already out there waiting? As humanity expands beyond the solar system, one question looms over everything. Are we alone? If we are the only intelligent species in the galaxy, our path to dominance is clear: spread, colonize, and master the forces of nature until the Milky Way bends to our will. But if we are not alone, the rules change entirely. Suddenly, we are not just explorers, we are competitors. And in a universe ruled by the laws of physics and survival, competition can mean only one thing: conflict. The idea that we might one day meet an alien civilization is both thrilling and terrifying. If they are peaceful, we could share knowledge, trade ideas, and perhaps even unite to shape the future of the galaxy together. But what if they are not? What if they see us not as equals, but as a threat? Human history is filled with examples of technologically superior civilizations encountering less advanced ones, and it has rarely ended well for the weaker side. If an alien species had a million-year head start on us, would they even recognize us as intelligent? Or would they see us the way we see ants: insignificant, expendable, and easily controlled? This is the core of the Great Filter Theory, one of the most chilling ideas in modern astrophysics. The theory suggests that the reason we don't see evidence of advanced alien civilizations is because some great challenge, prevents intelligent life from expanding beyond a certain point. That challenge could be technological self-destruction, an inability to sustain interstellar civilizations, or it could be something far worse. What if the universe is teeming with silent, watching civilizations, each too afraid to reveal its presence, knowing that the moment they do, something older, stronger, and more advanced will come for them? If this is true, then controlling a galaxy would not just be about expansion, it would be about survival. We would need to become the strongest, the smartest, the most advanced civilization in the Milky Way before anyone else does. And that means developing weapons, strategies, and technologies that ensure we are not just another civilization that rises and falls, but one that endures. One possible approach is to develop self-replicating probes, machines capable of traveling between stars, harvesting resources and constructing more of themselves. These von Neumann probes, named after the mathematician John von Neumann, could spread like a virus, expanding humanity's reach exponentially. Some scientists speculate that if a civilization wanted to take control of a galaxy, this would be the most efficient way to do it. Instead of sending massive fleets of colony ships, we could send small intelligent machines, programmed to build, explore, and expand without human oversight. Over thousands of years, they could terraform planets, construct massive energy harnessing structures, and prepare entire star systems for human arrival. But if we can do this, so could another civilization. If we assume that other species have already developed similar self-replicating machines, the galaxy might already be filled with dormant probes, waiting, watching, searching for signs of new intelligence. Some theorists even suggest that UFO sightings on Earth could be evidence of such machines, quietly observing us, determining whether we are a species worth engaging or eliminating. If humanity ever hopes to control the galaxy, we must prepare for the possibility that we are not the first civilization to try. But let's assume for a moment that we are alone, that the Milky Way is empty, waiting for us to claim it. Even then, controlling an entire galaxy is not as simple as just expanding forever. There is a fundamental problem with distance. Even if we developed near light-speed travel, communicating between different parts of the galaxy would still take thousands of years. A government based on Earth would have no way of ruling over colonies spread across 100,000 light-years. By the time a message arrived from one end of the galaxy to the other, entire civilizations could have risen and fallen. This means that a true galactic civilization would not be a single, centralized empire, but a vast, decentralized network of independent human colonies, each adapted to its own star system. Over time, these colonies would evolve, technologically, culturally, and even biologically, until they became almost unrecognizable as the same species. Some might merge with artificial intelligence, becoming machine-based life forms. Others might modify their DNA to survive in extreme environments, transforming into entirely new branches of humanity. Eventually, the question of control might become meaningless. Instead of one civilization ruling the galaxy, there could be millions of distinct human societies, each with its own way of life, its own goals, and its own understanding of the universe. But what happens when these different human civilizations come into conflict? Would war become inevitable? Would factions rise and fall, each seeking dominance over the others? Or could there be a future where peace and cooperation prevail, where the galaxy is not ruled by conquest, but by unity? The answer to that question may determine not just whether humanity controls the Milky Way, but whether we survive at all. And that leads us to the final question. If humanity does one day control an entire galaxy, what comes next? Is there something even bigger out there? Could we one day expand beyond the Milky Way, reaching into the deepest voids of the universe itself? And more importantly, should we? If humanity one day controls the Milky Way, we will have achieved something no species in Earth's history has ever accomplished. We will have risen from a single fragile planet to become the dominant force in an entire galaxy, a civilization spanning hundreds of billions of stars, harnessing energy on an unimaginable scale, shaping worlds, creating new forms of life, and perhaps even rewriting the laws of reality itself. But then comes the inevitable question, what's next? When we look at the night sky today, we see the Milky Way as a vast ocean of stars. But beyond it, stretching into infinity, are hundreds of billions of other galaxies, each filled with their own stars, their own planets, and potentially their own civilizations. If we manage to master our own galaxy, does that mean we stop? Or does it mean we take the next step, expanding outward from galaxy to galaxy until we become a force that spans the entire universe? The challenge of intergalactic travel makes interstellar travel look easy. Even at the speed of light, reaching the nearest galaxy, Andromeda, would take over 2 million years. Even if we mastered near light speed travel, the distances between galaxies are so extreme that traditional spacecraft, no matter how advanced, might never be enough. If we truly want to control more than just the Milky Way, we may need to transcend the limits of space and time itself. Some theories suggest that a sufficiently advanced civilization could manipulate space-time, creating shortcuts through the universe using wormholes or artificial warp drives. Instead of traveling from one galaxy to another in millions of years, we could step through a portal and emerge on the other side almost instantly. But bending space-time requires energy levels beyond anything we currently understand. Some physicists speculate that controlling dark energy, the mysterious force accelerating the expansion of the universe, might hold the key. If we could harness and manipulate dark energy, we could potentially reshape space-time itself, opening pathways between galaxies, or even between different universes. Yes, universes. Because if there's one thing modern physics has taught us, it's that reality may be far stranger than we ever imagined. Some theories suggest that our universe is just one of many, an infinite multiverse of parallel realities, each with its own laws of physics, its own possibilities. If humanity one day reaches the limits of our galaxy and finds that there's nowhere else to go, would we stop? Or would we find a way to break through the boundaries of our universe itself? At this point, we have to ask, what does it mean to control a galaxy? Is it about physical expansion, Spreading our species as far as possible, conquering star systems and building megastructures? Or is it about something deeper? The ability to manipulate the fundamental forces of nature, to create and destroy worlds at will, to ascend to a level of understanding where we are no longer just biological beings but something more, a species that doesn't just exist in the universe, but becomes the universe. The most advanced civilizations imaginable, what scientists call Type 4 or even Type 5 civilizations, wouldn't just control a galaxy, they would control the very structure of reality itself. They could create stars, shape black holes, and perhaps even engineer entire new universes. If we reach this level, we might not even need to travel between galaxies. We could simply create new ones, sculpting existence to our will. But this brings us to the most profound question of all. Should we? If we reach this point, will we still be human? Or will we have become something entirely different, something so advanced that our past, our history, and even our very identity as a species no longer matter? If humanity conquers a galaxy, does humanity still exist, or does something new emerge in its place? This is the final mystery, the ultimate fate of an intelligent species that has mastered its galaxy, transcended its limitations and reached into the deepest unknown. Will we find paradise or oblivion, enlightenment or extinction? The only way to find out is to take that first step, and maybe, just maybe, that step begins today. What do you think? Will humanity ever control an entire galaxy? Or are we destined to remain a tiny, fragile species in the grand cosmic ocean? Let us know in the comments below, and if you enjoyed this journey through the future of civilization, give this video a like and share it with others who wonder about our place in the cosmos. Thanks for watching, and until next time, keep looking up because the future is waiting.